Okay, guys. So far, we have learned how to factor a trinomial or quadratic equation. We know how to solve a quadratic equation by factoring it and then using the zero product property to find the x-intercepts, which are the answers. We also know how to, well, no, we haven't learned how to graph it yet. That's all we know. We only know how to factor it and find the values of x. Factor and use zero product property. Remember that when we're solving quadratic equations, we're looking for their x-intercepts. If this is the quadratic equation, that's your parabola. Remember, we're looking for these points right here, the x-intercepts, okay? Just want you to keep that in mind because after these sections, I'm going to go into graphing. And that's what we're looking for, the points that the x-intercepts are located. That's the solution to a quadratic equation. So, there are several ways to solve a quadratic equation or function. And remember, the quadratic equation is ax squared plus bx plus c, or f of x equals ax squared plus bx plus c, which includes, these are all the different types of ways that we can solve it. Graphing, which we're going to learn. Sorry about that. Graphing, which we're going to learn. Factoring, which you already know. Square root method, you already know that one. That's the one where it says something like x squared plus, or x squared minus 9 equals 0. Then you add 9 to both sides, take the square root, x would equal plus or minus 3. So we know that one. Completing the square is what we're going to do today, and using the quadratic formula is what we're going to do tomorrow. So today we're going to learn how to complete the square. Completing the square allows you to transform unfactorable trinomials. Remember when we got to those questions back in the past where I said, okay guys, as long as you get to that to the final equation, if it's unfactorable, just leave it like that. Remember when we did that, especially for unit rate and distance and all that stuff? We don't have to worry about that anymore. We're going to know how to do it now today. So if it's unfactorable, you can turn it into a factorable perfect square trinomial. So that's the goal, to turn a trinomial that is unfactorable into a factorable trinomial. How does it work? All right. You can make a perfect square trinomial from x squared plus bx by adding, once you have the x squared and the x alone, once you have the x squared and the bx alone, if you add b over 2 squared to both sides, well, actually, don't worry about both sides right now. If you just add b over 2 to that binomial, you're going to get x squared plus bx plus b over 2 squared, which will give you a perfect square trinomial. So if I just give you a binomial with an x squared and an x, and I want to make it a perfect square trinomial, all you got to remember is find b divided by 2, square it, and add it. And that will form a perfect square trinomial. Before we learn how to solve a quadratic equation by completing the square, let's practice the simple act of completing a square. So, for example, how do we do this? Okay, complete the square for the given binomial. You got x squared minus x. So my first thing, identify b. What's your b here? B is no, just the negative 10. Bx is not the b, just the b. Thank you, sir. Step 2, find b over 2 squared. In parentheses, it would be negative 10 over 2 squared. So leave it like this. Do not find the actual value of it yet. Step 3, add the value of b over 2 squared to complete the square. So you're going to have x squared minus 10x plus a negative 5 squared. Do not make that a 25. Right now it's easy, but later on there's going to be fractions and there's going to be a reason for my madness. Step 4, rewrite as a square of a binomial. This is how you write it. Take the square root of the first one, which would be in this case x, and then whatever is inside of here, don't worry about the stupid exponent. Don't worry about that. Whatever's inside, so basically the value of b over 2, that's what you bring out here. And then you square the whole thing. And you're done. Now, I'll prove it to you. I'll prove it to you that that works. X squared minus 10x plus 25. Isn't that a perfect square trinomial? X minus 5 times x minus 5. Isn't that x minus 5 squared? Do you really want to go through all of this work? No. And especially when you get into fractions, it's not going to be so easy. So whatever is inside of this parentheses, the b over 2, that's what you put over here. That's how you complete a square. That's how you complete a square. We haven't solved anything yet. All we've done is completed a square. Does that make sense so far? You find the b, put b over 2 squared, place that as your third term, take the square root of the first, boom, square root of the second, whatever's inside of those parentheses. Sir? Correct. The question was, so Mr. Morrow, you don't just write this as a 25. You can, Anthony, but I'm going to suggest not to. Because later on, as we get more difficult, you're going to have a b over 2 that looks something like this. Do you really want to square that and then find this and then factor that out? No. So trust me, stick to what's inside of that parentheses. Let's practice and you'll see that it's not as bad as you think. Let's just complete these squares. So this would be x squared plus 6x plus b over 2 squared, which is 3 squared. So that's going to equal x plus 3. Done. Squared. Took the square root of the first, and then the inside of the b over 2. X squared plus 8x plus b over 2 squared. So that's going to be x plus 4 squared. This down here, x squared minus 32x plus a negative 16 squared. Notice how I put that in parentheses, guys, because I always put the b over 2 in parentheses. Now, it's x minus 16 squared. Square root of the first, and then whatever's inside of here with its sign. It was negative 16 in here, so it comes out negative 16 here. This bad boy, this is what I was talking to you about the fraction ones. This is going to be x squared minus 5x plus a negative 5 halves squared. Do not turn that into 25 fourths and then try to factor that out. You're doing one extra step to go back a step. Don't do that. This is going to be x minus 5 halves squared. So square root of the first, and then the inside of b over 2 squared. Does that make sense? Promise? Yes, sir. Okay. We're creating a perfect square, son. So the question was, why do you do that? Okay, look. I already showed you, but I'll show you again. This is x squared minus 5x plus a negative 5 halves squared. You want to do it the long way? That's fine. X squared minus 5x plus 25 fourths. Now you're going to have to factor this, buddy. And I hope that you know how to factor this. Because this is going to be x plus 5 halves. No, it's a minus. X minus 5 halves times x minus 5 halves. I'm not trying to be a jerk, but not many people are going to know that's 5 halves. I know you know it. I know you do. But that's not the point. When you're applying it, you're on the test, you're nervous, you may not get that. So if you want to go here and then go backwards and then do a third step, well, then God bless you. Or you could follow my directions and say, first, square root the first term, And whatever's inside of the b over 2 squared, put it next to the x and square it. If you find that more difficult than doing 3 steps, then do the 3 steps, sir. Sir. Of course it changed the problem, and you're going to see that now we're solving, I got to do to the other side. But right now I'm just doing the skill of knowing what to add. What is my b over 2? And how do I factor that out? It's just the skill of completing the square. We have not solved anything yet. You with me, guys? Okay. Next, how to solve a quadratic equation function by completing the square. Okay, here we go. This is a good one. Okay. Number 1, isolate the ax squared plus bx and divide a to both sides, unless a equals 1. Basically, they want you to get the x squared and the x term alone, but they do not want a coefficient in front of the x squared except for 1. So if you want, right off the bat, divide everything by 3. That gives me x squared minus 4x plus 2 equals 0. Is everyone with me so far? Okay? Now I want to isolate the x squared and the x. So I'm going to subtract 2 to both sides. So I'm going to have x squared minus 4x. I'm going to leave a space equals negative 2. Is everyone with me so far? Because that's step 1. Sir? No, I didn't factor out of 3. I divided 3 to both sides, sir. I divided 3 to both sides, sir. Number 2, complete the square. But just like my boy had said, Mr. Morrow, if you just do it to one side, you're not going to keep the equation equal. And of course not. So you're going to complete the square by adding b over 2 squared to both sides. So what's my b over 2 in this case? Negative 4 over 2, right? It's just negative 2. So I've got x squared minus 4x plus my b over 2 squared. It's going to be negative 2 squared. Am I going to calculate this or leave it like that? Leave it like that. Equals negative 2 plus, on this side you can calculate it, negative 2 squared is 4. Now, guys, what does this turn into? X minus 2. Remember, square root of the first term, and then whatever is inside of the b over 2 squared. Equals negative 2 plus 4? It's 2. Now it's Mickey Mouse time. How do I get rid of that power of 2? Square root. So I got x minus 2 equals plus or minus the square root of 2. Add 2 to both sides. Ding dong, the witch is gone. 2 plus or minus square root of 2 is your answer, sir. Talk to me. Oh, and I didn't do the steps. Stupid. Step 3, factor the trinomial, which we did. Step 4, find the square roots, which we did. Step 5, solve for x, which we did. We're going to do another example. But questions so far? Okay, I'm going to take that as a no. Yes, sir. For the first step, could you subtract the 6 first and then divide it? Yes, sir. As long as it is mathematically legal, yes. Thank you, sir. Sir. Okay, you do not have to check for extraneous for these. No, sir. And sometimes you're going to get imaginary answers as well. And that's fine. And that's fine. Does that make sense so far? Okay. Let's see what we got here. Next. Oh, okay, let's do it. Let's knock this out. Solve the equation. Okay, we're going to solve this. You know you're not going to be able to factor this, right? So let's get the x squareds and the x together on one side. Let me pause real quick. Okay. All right, guys. Some of you guys I saw were working on it and doing really well. I'm proud of you. Some of you guys are a little confused, so that's why we're going to do it. That's why I teach, okay, to learn. Sorry about all those noises today, guys. It is totally annoying to me as well. Okay. First things first, I'm going to subtract x to both sides. I'm going to subtract 3 to both sides. So I have 2x squared minus 2x equals 6. I cannot have a coefficient other than 1 in front of my x squared. So I'm going to divide 2 to both sides, giving me x squared minus x equals 3. Okay, remember what I said, guys. What's the b here? This may help you. What's the b? Negative 1. What's b over 2 squared? What is it? Negative 1 half squared. Am I going to calculate that value? No. So I'm going to have x squared minus x plus b over 2 squared. You got to add it to both sides. Are you with me?
Yes, sir.
You guys with me?
Yes.
So then this is going to be, what does this turn into? X minus 1 half squared equals 3 1/4, which would be 13 over 4. Is everyone with me so far? Yes?
Yes.
Okay, now I'm going to square root both sides. Cancel, cancel. So I'm going to be left with x minus 1 half equals plus or minus square root of 13 over 2. Because the square root of 4 is 2. Then I add 1 half to both sides. And x would equal 1 half plus or minus square root of 13 over 2. That is my answer for number 1. If you're stuck, you got to let me know, guys. And I'll be happy to help you. It is my job. Continue? Okay. Okay, now we have y equals x squared plus 3x minus 6. First things first, make that y a 0. So 0 equals, because we're solving for the x-intercepts, so we make y 0. Now add 6 to both sides. So I get 6 equals x squared plus 3x plus b over 2 squared, which is going to be 3 halves squared, which I add to both sides. Are you guys with me? Okay, 6 plus 3 halves squared, that's going to be 9 fourths plus 6, right? So that goes to 4, that goes to 24. So that's going to be 33 fourths. So 33 fourths equals, what does it equal? Remember, square root of the first plus what's inside of the b over 2. Good job, son. Squared. How do I cancel out that power of 2? Square both sides. So I got plus or, come on, Morrow. So I've got plus or minus square root of 33 over 2 equals x plus 3 halves. Subtract 3 halves to both sides. And my answer would be that right there. X equals negative 3 halves plus 33 plus the square root of 33 over 2. It's actually kind of fun, this one. It's actually kind of fun. It's kind of like little puzzle pieces. Okay, I don't know if out there in online world they're listening to my class, but they are laughing at me and making fun of me. That's fine. That's fine. Let's do another one then. The only way we're going to learn this is by doing it. First things first, let's get the x squared and the x alone. So minus 4 to both sides. So I got x squared minus 4x equals 96. You guys with me?
Yes, sir.
What's my b? Negative 4. So what would my negative b over 2 squared be? Negative 2 squared. So I'm going to have a negative 2 here squared plus a negative 2 here squared. What does this turn into? X minus 2 squared. Again, how? First term, square root. Then whatever's inside the b over 2, it goes right there. You square it, that equals 100. This one's going to be a real easy one. Square root both sides. X minus 2 equals plus or minus 10. Add 2 to both sides. Now please pay attention to this. That means that x equals 10 plus 2 and negative 10 plus 2. Because it's plus or minus 10 plus 2. So x is going to equal 12 or negative 8. Come again, son? No. We already answered the extraneous question, and the answer was no, sir. Okay? Does that make sense so far? Promise? Okay. Last one. And then we will go, okay? I know you're staying a little, like a minute or two extra, but that's okay. You're going to be fine. First things first, what do I do here? Yeah, you could divide 9 and everything if you want. Sure, why not? I wouldn't have done it that way, but that's fine. So it's going to be x squared minus 4/3 x. Guys, please. Minus 2/9 equals 0. So now I'm going to add 2/9 to both sides. Please pay attention to this. So I've got x squared minus 4/3 x, I'm going to leave a space, equals 2/9. Is everyone with me so far? What is my b? Negative 4/3. What is my b over 2 squared? Okay, I've heard a lot of mumbling. Guys, negative 4/3 divided by 2, stay, change, flip. It's negative 4/6, but it's going to be negative 2/3, which is negative 2/3. You with me, guys? Yes? So this is going to be plus a negative 2/3 squared plus a negative 2/3 squared. What does this turn into, that perfect square trinomial? X minus 2/3 squared equals negative 2 cubed squared, 2 over 3 squared is 4/9 plus 2/9 is 6/9, which is 2/3. Now, take the square root of both sides. X minus 2/3 equals plus or minus square root of 2/3. Add 2/3 to both sides. And x will equal 2/3 plus or minus the square root of 2/3. And that is your answer. Thanks for picking up so quickly, guys, and really focusing on this. Your homework is valid. Your test on Friday is valid. God bless you. Have a great day.